Lactic acid, CH3CHOH, has one acidic hydrogen. A 0.10 molar solution of lactic acid has a pH of 2.44. Calculate Ka. Well, first, in order for us to do this problem, we have to ask ourselves two questions. The first question is, are we dealing with an acid or base? Since it says lactic acid in the question, that means we're dealing with an acid. And the second question we have to ask ourselves, is it a weak acid or a strong acid? If you memorize all of the strong acids, which is only 7 of them, you will know that this acid does not belong to that list and therefore it is a weak acid. Organic acids that have COOH are weak acids. That's another way to know this. If you know that your problem has a weak acid in it, then you will have to do the ice chart, and we will look at how to do the ice chart. Before we get to the ice chart, we need to write the equation for the dissociation of acid. I wrote the generic equation to the right. For the generic acid HA, it dissociates into H plus and A minus. So basically it gives off one proton or one hydrogen, and then we have its conjugate base left over as A minus. We can apply this equation to this acid, and so we write the equation CH3CHOH, COOH. It dissociates into H plus and its conjugate base, which means we just have to take this hydrogen off and we get CH3CHOH, COO minus. You could write this formula or you could even write the generic formula depending on your professor. Both would be correct. Next, we write our ice chart. We write I, which stands for initial, C stands for change, and E stands for equilibrium. Looking at our numbers, initially we only have lactic acid and its concentration is 0.1 molar. So we will put 0.10 here. We do not have any H plus or CH3CHOHCO minus. By the way, this has to be a double way arrow because it's a weak acid, so it goes both ways. Initially, my concentration of H plus and the conjugate base is 0 because lactic acid has not started dissociating yet. As lactic acid dissociates, what is the change? Well, lactic acid will decrease by a certain amount, let's call it X, and H plus will increase by amount of X, and the conjugate base will increase by X as well. How do we know that this is minus and this is plus? If we start with 0, we cannot have less than a 0. So the right side has to increase, and if the right side is increasing, the left side has to decrease to accommodate for that. For equilibrium, we just add the initial and the change values. So we will get 0.1 minus X, X, and X as our equilibrium values. Now that we have finished writing the ice chart, the next thing that we should do is we should write the Ka expression or the equilibrium expression for the acid. The equilibrium constant expression is basically the concentration of products over the concentration of reactants. So I wrote H plus in brackets. Brackets means concentration of H plus times the concentration of the conjugate base over the concentration of the acid, close the bracket, and these are equilibrium concentrations, so we can put our equilibrium values instead of them, and we will get X for H plus times X for the conjugate base, so X squared, divided by 0.1 minus X, which is the concentration of the acid at equilibrium. We do not know these values yet. The question is asking to calculate Ka. We are very close. The only thing that we need to calculate Ka is if we would know this X, we could plug it in and we could get our Ka. How can we know this X? Well, the question tells us that The pH of the solution is 2.44. So we know the pH. What is pH related to? Well, pH is related to H plus or H3O plus. The concentration of H plus is equal to 10 to the negative pH. And if we plug it into our calculator, we get 0.00363078 as our concentration of H plus, and that is our equilibrium concentration. Now, if we know our equilibrium concentration of H plus, which is X, then we can plug it in everywhere. So we can plug this H plus, we can say that this is indeed our X, and we can plug it into our expression. Once we plug it into the calculator, we will get 1.4 times 10 to the negative 4. Notice that this has two significant figures. Because this has two significant figures, I'm choosing the number with the least significant figures, which is 2. So my answer must have two significant figures as well. This is Maya from Transformation Tutoring. Please like, subscribe, and ask me questions, and I will see you during my next chemistry video.